Hello everyone, welcome to the introduction video of the exercise session for week 8. So for this week, we will introduce you to the PyTorch platform. So you can start your project too with different deep learning algorithms. We will also briefly discuss the vanishing gradient problem in neural networks as in problem 2. So for the first practical problem, please familiarize yourself with the basic PyTorch operations. You can use these two official PyTorch tutorials. The first one, uh, you, the first one is a 60 minutes quick review to better understand the PyTorch tensor library as well as a high-level intro for the neural network. Well, the second one, it introduces the fundamental concepts of PyTorch through some self-contained examples. It starts from the NumPy, which you should have seen and used in your previous project and exercises. And you will also know that in your previous experiments, you need to manually implement the backward pass, get the derivatives, and use it to update the model. But this scheme is not feasible for large and complicated neural networks. And that is why we need to use the PyTorch as as one of the standardized tools to uh, develop a deep learning research. Yeah, to develop deep learning. So the tutorial uh, introduce the fundamental concept. Uh, the most fundamental concept of the PyTorch, which is the tensor. And the tensor can keep track of a computational graph and gradients with the GPU support for acceleration. The tutorial also contains the introduction to the automatic differentiation, which allows us to automate the computation of backward passes in large complicated networks. And it will also describe a very powerful uh, module, which is dot module, which it is very powerful and it can help us to define complex operators and we can automatically take derivatives over different sequences. So if you are not familiar with PyTorch, I would highly recommend you to first check these tutorials before starting the exercise. So let's go back to the exercise itself. So for the problem one, we will first ask you to implement a basic linear regression. Here we try to build a self-contained class. So please do not use the NN dot module. And you need to modify these three functions and and in the end you will get a differentiable model and it can make a random prediction based on this random input. And you will also need to implement this MSE function so it can be used for the training. Once we have this model and we have the loss function, we need to define the training pipeline in PyTorch. And you need to modify these three steps here. And the expected outcome is something like figure 1a. So for the exercise 2 in problem 1, we would like to set up a very simple example and help you to better understand the PyTorch operators. I mean, the most basic PyTorch operators. And for the XS3, we would like to introduce the NN package in PyTorch, and you will be asked to re-implement your previous linear regression class by using this NN.module, and you will understand why it is so helpful when we have a large neural networks. And in the end, you will be asked to implement a more complicated neural network, which is a two-layer NLP, and it will output a nonlinear feature line as in B.1b. So up to now, I just briefly introduced the the practical problem one, and we hope you can get started with the PyTorch, and it will help your project too. And for problem two, it is a theoretical problem, and you need to do some simple derivatives on the sigmoid function and consider the number of the nodes per layer. By using these two hints, I think you can reach the final conclusion, and you will understand why a deeper network have the issue of the vanishing gradients.